Okay, now we will come to the different networking devices. Because on the process of OSI model, we have understood that first computer will be there, then media will be there, then switches will be there, then routers, and then firewalls. So we need to understand what other different devices will be involved inside the network. First, router, we already understood what is router. Router mean which will deal with packets over the internet, which we will take it outside the network. So function of router is connecting multiple networks together, because our router will be connecting to multiple other networks. So that is called router is a device which is connecting multiple networks each other, and the direct traffic from one to another, which is called routing. So routing will be involved with the help of routers. What are the uses? Connecting home or to different internet and directing between different networks, that is called routing. What are the features? Provide the IP addressing, offer security with the firewalls, because that router will be connecting to security. So that is providing the security also. Can be wired or wireless. These router can be wired or wireless. Like at home, you have Etisalat router. That Etisalat router is providing cable connection also and Wi-Fi connection also. That is called both. So it can be wireless or it can be wired. So that router can be wired also and wireless also. The next device is switch. The switch is used basically to connect devices each other. Like it's a general device, because physical connection cable have a limit, like 100 MB data can be transferred on that cable. But Wi-Fi cannot show that how much data can be transferred, because Wi-Fi is not limited to speed. Because sometimes this Wi-Fi will be having very good speed, sometimes it will be very low. Why? Because the other factors from outside will be affecting on that Wi-Fi. Other factors cannot go inside wire and cannot hold the speed, because wire is having proper communication inside, close communication. So 100 Mbps wire mean 100 Mbps data per second can go, but Wi-Fi we cannot match. For example, fan is on, that fan air can compress the data signals, the speed will become low. For example, your Wi-Fi router is nearby the accelerator is ongoing, शोर आ रहा है, वो भी उसको कंप्रेस करेगा. So many factors can affect the Wi-Fi speed, but cable speed cannot be managed from outside. One factor is there. If cable is going and electricity cable is also going, that electrical signal can make compress the physical cable signals, but that only one factor. But for Wi-Fi there are multiple factors. If you turn on the fan, that will affect. If the lightning effect is more, that will affect. If nearby electric current, it will affect. If it is more light, then it will affect. If it is outside going and some rain is coming, it will also affect. If thunderstorm is coming, it will also affect. अंधेरी आ रही है, वो इफेक्ट करेगी. कुछ भी फैक्टर है वो सब इन्वॉल्व हो जाते हैं, क्योंकि वो बिट्स प्रॉपर तरीके से जा नहीं सकती. सो वाईफाई विल ऑलवेज बी अनएम्बिगुएट. Sometime it will be very fast, sometime it will be very slow. When it is slow, you have to understand which factors involved to make it slow. Cable will not affect, because that will be giving very good speed. So that is why recommended way is to use cable. But nowadays Wi-Fi technology is becoming very advanced. Before it was possible 100 Mbps, now it is possible in GBs in Wi-Fi also. So if you are using very good Wi-Fi connection, that maybe it is also slow. So the second device is switch, which is general device to connect multiple computers each other. What are the common uses? Connecting computers, printers, servers within a network. Like all devices, we can connect to that switch, and that switch will provide the communication. Features: operating data layer we already understood in OSI model. Switches work on data link layer, because this connection is made from the computer with the cable, and we are providing data link. So data link will go to switch first. That is why switch work on layer 2. The third device is hub or bridges. Basically these two devices we don't use now, because these were older than switch. Hub was older device which was sending traffic to all. For example, if 10 computers are connected to hub, and that hub want to communicate data from 3 to 5, but whenever 3 will send data for 5, hub will send it to all. It was not intelligent device. It was not working with the MAC address table. So that is why they were just dumb devices. Whenever some data was coming from one port, and the hub was sending to all. Whoever the have MAC address, they will take it and other will discard it, but it will waste the communication. So that is why hubs were just only one broadcast domain devices. Also bridges were limiting this, because if you have connected 10 devices to bridge, but bridge was also sending broadcast. But if you are connecting to bridge, that broadcast will not go to the second bridge. That was the difference between hub and bridge. For example, if you are connecting two hubs, one hub have 10 computer, one hub have 10 computer. If someone is sending traffic singly, hub will also transfer it to the second hub, and it will also go to the 10 computers of second hub. So the broadcast will go whenever 10 hubs connecting, all hubs will receive that, and it will go all over the network. But what bridges do, bridges also work like hub in one network with one bridge. But when it will go to the second bridge, that second bridge will not receive the broadcast. Their network will remain different. So that was the difference only between hub. Hub was sending to all hubs, and bridges were carrying only traffic to single bridge. But that was not also enough, because inside one bridge also 24 ports are available. So it was going to all 24. So that is why they have replaced the hubs and bridges with the help of switch. Switch is sending traffic one to one only. So switch is dealing with the help of MAC addresses. First time, whenever someone is sending, no, inside there is a memory. Switch is having memory. Whenever someone sending traffic, they will send first time broadcast to all. All people or all computers will send their MAC address to switch. Switch will build a table inside. That is called MAC table. So everyone is sending, yeah, there is a memory inside. So inside physical memory, there is a one table which is called MAC table. So they will build MAC table, and everyone is sending their MAC addresses they are putting there. For example, switch have 10 ports, port number 1, 2, 3, 4, 5. So it will build table like this inside the memory, and here it will be writing port number, and here it will be writing MAC. So for example, 5 computers are there, 1, 2, 3, 4, 5. So it will write the port numbers here. Port number 1 connecting to the port number 1, port 2, port 3, port 5. So whenever someone start communication, it will write the MAC address here. And also the second, third, fourth, and 5. So all MAC addresses are putting against the port number. For example, on port number first, Tanveer is connecting, my MAC will be there on the list. Port number 2, you are connecting, your MAC will be against port number 2. Whenever I will try to send traffic from 1 to 2, switches will check the MAC address and they will send it one by one. They will not send it to all. But first time, whenever switches don't have the MAC address table, they will send one broadcast. One time broadcast will go to everyone. Everyone will send the MAC address, and then next time, whenever you will send traffic, it will go only one to one. It will not go one to all broadcast. So switches built this table. Hubs and bridges were not building the table. Whenever someone was sending data, because they don't have the database, they don't have the record, they were sending to all. I don't know where it want to go. So when everyone gets it, inside the frame there is a MAC address. So whoever have MAC address, for example, it was for me, I will catch it, and the rest will say not for me, not for me, not for me. They will cancel. So hubs and bridges were sending traffic without intelligence, without this MAC address table. So that is why they were not intelligent devices. Bridge was little bit intelligent. When one bridge sending broadcast to the other bridge, it was not receiving. But hubs were sending all across the net. So these two devices were not able to handle the communication. See, if it is saying common uses inside the bridge, that simple network setup where security and efficiency is not priority. Because here security and efficiency will not happen, because there is no table, no one know where traffic is going to, who is receiving, who is not receiving. Features operate like physical layer. They are working like a physical layer, because switches are dealing with MAC table, data link layer, that are intelligent devices. These were not intelligent devices. They were just dealing with the streams of bits coming from here, going there, coming from here, going there. So that was working on the layer 1. Just simple like computers. Coming, going, coming, going, coming, going on. Okay, the third device is modem. What is mean by modem? Modem is basically a modulator, demodulator devices. Modulation mean If data is going from here with the help of bits, it is converted to signal. That is called modulation. Like data is leaving from computer as a digital data and it is going to cable. Cable don't know digital data. Cable knows signals. So when we are converting our data to signals, it is called modulation. And when it will go as a signal from the cable and the other end will receive the signals and then it will convert it to back data. So that is called demodulation. If you are converting over bits to signal, it is called modulation. And again, we are converting from signal to bits again. That is called demodulation. So that is why the called modem means MO mean modulation and DEM mean demodulation. So the process of modulation and demodulation with the help of some device. Now, before it was coming a separate device, we have to connect this NIC to that modem and then that modem was connecting to switch because that modem was converting data from bits to signals for cable and then the other side was also having another modem which was converting signal to data back. But nowadays they have just put it this modem as a chip inside network interface card. Now we are not using separate modem device. Now modem is there. Yeah, now modem is there, but modem as a chip we have implemented on the NIC. Whenever NIC want to connect data to cable, first it will give it to NIC inside chip modem. Modem will convert it from bits to signal and it will give it to cable. Before it was giving outside to modem physical, now it is just inside a chip on the NIC. And NIC will take the bits, it will give it to modem chip over the NIC, it will convert and then it will give it to cable. The other side when it will receive, again the NIC will convert, demodulate it and then give it to computer. So yeah, same process is there, but that process will be opposite. Inside modem is working. If I am sending data, then it will be modulation. If I am receiving data, then modulator function will work. So basically modem is divided into two aspects. One is bits to signal and one is signal to bits. So if you are converting bits to signal, that is called modulation. And if you are converting back signal to bits, that is called demodulation. So modulation and demodulation, before basically these convert data from computer into analog signals and that can be transmitted over the lines, cable systems, vice versa, and it enables internet connectivity. Because if you are not modulating, demodulating data, your cables will not take as a bits because cable only understand with the help of signals. What are the features? Because can be DSL, cable or fiber optic based, because nowadays whenever we are connecting internet connections from outside, so our data should be going outside with the help of signals, not bits. Access point, we have already understood access point. Access point, if we are using Wi-Fi technology, wireless LAN, then the switch will not work. Then there will be another access point that is connect with the help of Wi-Fi. That is access point allow wireless devices to connect via network. Like for example, if I don't have physical NIC and cable, I have network Wi-Fi NIC, then I cannot connect it to switch because switch will be having ports, but AP access point don't have ports. It will connect through Wi-Fi. So access point is used to connect with wire network with the help of Wi-Fi. What are the using? Expanding the wireless coverage in large building. For example, sometimes in big buildings we don't have all the physical switches to take cables around. So we just connect one access point that will be providing Wi-Fi. Features operates at data link layer because switches are dealing with the data link layer, same functions without cable. They are doing AP and AP also working on layer 2 because these are two same devices. One is working with cables, one is working with without cable, but both are working on layer 2. Can be standalone or integrated to the router. It can be a separate access point. Sometime inside the router access point is available. For example, at home TAClouds router, we don't have a separate access point. We have the router and inside the router access point facility is also there. So that access point and switch also, three capability we are having at home. For example, we can connect cable to that router. It means there is a switch inside. We can connect Wi-Fi to the same router. There is access point inside. And we can connect it to outside the world, router is there. So nowadays at home TAClouds is providing router, but that is not only router, that is switch also, that is access point also, that is router also. So three devices is common together. Now we are not, if they are not doing like this, they have to provide three devices. Separate Wi-Fi router to connect outside, separate switch to connect physical computers, and separate access point to connect Wi-Fi. So if they are not making one device, they have to provide three devices. So what they have done, they have made three separate chips and put it in one device. That is called router, but that is not actually router. Yeah, that is not actually router. That is basically a general purpose device, which is having access point also, which is having switch also. Okay, NIC, network interface card, we already know there are two types of NICs. One is physical NIC and one is wireless NIC. Physical NIC is providing connection to the cable and logical NIC is providing Wi-Fi connection. So these are two types. Common use is providing the network connectivity for the computers. Dongle is also wireless NIC because that is not connecting cable. That dongle is providing Wi-Fi. So this wireless NIC. Seventh is firewall. We already understood what is firewall. Firewalls mean that is connecting outside the network, which is making possible, which can go out, which can come out. So that are basically network security devices, which monitors the traffic and controls who is coming and who is going. Common use is protecting the network from unauthorized access or cyber security or cyber attacks, because someone trying to attack your network, they will control it. Filtering the traffic means they are filtering who can use Facebook, who can use YouTube. So we can put filter on that firewall. If I am going outside, I am working in office environment, I cannot use Facebook. So I have to disallow Facebook. So I will go inside firewall and I will put some rule that this guy with having this MAC address cannot go Facebook. So whenever you will use Facebook, open Facebook from office, it will block on the firewall. It will not go outside. So you will not get Facebook. So you have to do only work, not Facebook, YouTube. So we can block or we can filter. Hardware based or software based, we can make this firewall logically inside the router also, and we can separately put one box, physical box. What is gateway? Gateway means that is not a physical device. That is actually a gateway where you can go out or you can, it's like same gate at your home. Someone can come inside from gateway, someone can go outside. For example, basically your router is your gateway. So you can go outside via router and you can come inside. But nowadays this gateway term is not only used for router, because sometime organization are even not using router for going inside outside. They are using only firewall. So if there is only firewall, there is no router. So how we will say this is router? So firewall can be also having virtual router inside. So nowadays companies are not using routers. They are just having switch, and switch is directly connected to firewall, and that firewall inside have virtual router. Same like router at home. They are building inside access point and switch. But nowadays firewalls also have inside virtual router. So virtual router, but whenever someone is going through firewall or router, but we don't have router, how we will say that is router? So we can say that device is a gateway. Gateway means which device is, whether it is a firewall or whether it is a router, that is a connection point to go outside or come inside, that will called gateway. That will connect two networks, that different protocols, it transfer from data. For example, one router is sending one type of data and the other side is having different kind of data. So we are connecting two types of connections each other. Common use, company's internal network to the internet. Basically these gateways involved to connect your internal network to outside. Features, operates various layers of the OSI model. Now router was only working on third layer, but these gateways can operate multiple layers because they are dealing with multiple protocols. Can be hardware or can be software, same like router. It can be hardware or it can be. Last one is the repeater. Repeaters, we already understood that it's same like hub. Something is coming to it and it is giving the same, as it is. Why we are using repeaters? Because sometime we are sending traffic by cable. That cable is limited to only 100 meter. So after 100 meter, if I want to send traffic, I want to connect that repeater there. That repeater will take the lower signals and it will boost again for another 100 meter. And if I have to use until 500 meter, one cable after 99 or 98 meter, I need to put one repeater that will repeat the same signal. Same it's with Wi-Fi. If I want to send 5 kilometer Wi-Fi signal, but that is limit for signal is only for 1 kilometer. So after 1 kilometer, I need to put boosters. Like already these Wi-Fi connection, mobile connections are having these towers. So these towers also having repeaters. So after 1 kilometer, 100 kilometer, they have put it tower. Why? Because they will catch the signal. They will repeat to the next 100 kilometer. So these repeaters are taking the lower signals. They will boost for 100 kilometer again. And then again, there will be another repeater in wireless technology also and the wire technology also. In wire technology, for example, I am having this 24 floor building. So that is having floor to floor, for example, 1 meter distance. So after 1 meter distance, second floor will not get connection. So what I will do, I will put one repeater on the second floor that will be connecting to cable, and again floor to floor I can put repeaters, and I can take cable to 24 floors. That will be 24 meters. So after every meter, I will put one repeater physically, and that will be boosting my connection until 24 ports. Function is to amplify the regenerates the signal. Amplify mean it will boost the signal, and repeater mean it will regenerate the signal. Same signal they will regenerate. What are the common uses? Extending the range of the network. It will extend the range, and particularly large buildings or outdoor areas whenever we need to go outside areas. Improve the signal quality and network long cable runs. Whenever we need to go long and long and long, we will use repeaters. Same like cable network provider use this. Every time they have putting one box out there and they are putting one repeater there, their cable connection will boost the signal, and then it will go move and move. And for example, it is going to the rural areas. This is also operate at physical layer 1 like hubs, because hubs and bridges were not intelligent. This one is also not intelligent. This is just capturing signal and boosting. So these are not working something intelligent. So hubs and bridges and these repeaters, these are all layer 1 devices. Switches are layer 2 devices. Routers are layer 3 devices. Firewalls and all these layer 3 and layer 4 both devices. Firewall and security, and also gateway is the layer 3 and layer 4 device. Okay, Ji, we will wind up here, and if you have any connection, any questions in this, then you can ask. Basically, we have understood today what are the networks and what are the different types of networks like LAN, WAN, MAN, HAN, and after that we have divided it with the some operations, how networks work with the help of OSI model, like how layer by layer data is transferring from one place to another bit. And then in this operation, we understood that first there will be bits, then there will be frames, then there will be packets, and then there will be segments. After that, first layer, we will be dealing with computers and bits, and then after that, there will be switch, and then router, and then firewalls, and then we will go move on. And layer by layer, we will be going physical layer, then data link layer, then network layer, then transport layer will be handling the flow control. Session layer will be maintaining the session. Presentation layer will be making presentation of the data like encryption, compression, and all that. And at last it will go to the application.